So in the previous video, we had focused on taking the derivative of products of two functions. That is to say that we'll have two functions lined up next to each other and multiplied out. So, for example, a product of two functions would be 3x multiplied by sine of x. In today's video, we'll be focusing on taking the derivatives of quite the opposite. Rather than products, we'll be taking the derivatives of quotients. Quotients will be of the form f of x divided by g of x. And one really quick note that I would like to make about the quotient rule that did not apply for the product rule is that the order does matter in which you define your f of x and your g of x. In your product rule, it didn't really matter because they were being added anyway. However, the fact that this is a difference really does make all of the difference. So your f of x does need to be the function in the numerator and your g of x needs to be the function that's in the denominator in order to make the quotient rule work. So without further ado, we've got our formula right over here. This is exactly what we will be using to be taking all of the derivatives of all of the quotients. It's exactly the same application over and over. If you are familiar with how to use the product rule, then you're already familiar with how to use the quotient rule. Split things up into your f, your g, your f prime, and your g prime, and then you plug them all into the formula. It's very simple. However, let's go ahead and take an example to make things a little more visual on your end. If we wanted to take the derivative d by dx of the function x plus 1 divided by x minus 1. We would start out by doing the exact same thing that we did when we were taking the derivatives of products, and that is we will write out our f of x, our g of x, our f prime of x, and our g prime of x. So we will take our f to be the function in the numerator, our g will be the function in the denominator, and then we will take their respective derivatives. So our f of x will be our numerator, which is x plus 1. Our g of x will be x minus 1. And then our f prime of x will be the derivative of our f, which is just 1. And then our g prime of x will be the derivative of our g, which is also 1. And this calls for plugging things into the formula exactly as it's written right over here. We have f prime times g minus f times g prime, all of that divided by g squared. And essentially what that's going to look like is we will cross these just as we did in the product rule, so f prime times g, and then we will subtract off f times g prime. So we have 1 times x minus 1. So this will be 1 multiplied by x minus 1. Then we will subtract off f times g prime, which will be 1 times x plus 1, right, x plus 1, and then we will divide the entire thing by g squared. In this case, our g is x minus 1. So we will take x minus 1, shove it in the denominator right over here, and square it. That is the derivative of our function. If we wanted to clean it up a little bit, essentially we can drop the brackets and do a little bit of cancellations. These ones don't really do anything, so we can get rid of them. We'll be left with x minus 1 minus x plus 1 over x minus 1 squared. And then if we drop these brackets and distributed the negative, we would be left with x minus 1 minus x minus 1 all over x minus 1 squared. Now we can cancel out these x's right over here, so we have negative 1 minus 1. That leaves us with negative 2 in the numerator. So we'll have negative 2 over x minus 1 squared. And that is the derivative of our initial function. Now the quotient rule can get really messy, so make sure to keep everything in order and well organized. Otherwise you may get lost and you'll have a lot of difficulty picking up where it is that you left off. So I'm going to leave the quotient rule up there because it's not as easily memorized as the product rule most of the time. So say we wanted to take the derivative of a quotient of two functions. The quotient of two functions that we'll be taking the derivative of is, alright, this will not be a quotient of two functions, but it can be split into a quotient of two functions. So say we wanted to take the derivative of tangent of x using the quotient rule. So essentially what it is that we can do for this is we can split it up into its constituent functions, which is sine in the numerator and cosine in the denominator. So tangent of x is equal to sine of x divided by cosine of x. And then we can take the derivative of it using the quotient rule, which we had just learned. So our f of x will be what's in the numerator, which is sine of x. Our g of x will be what's in the denominator, which is cosine of x. Our f prime of x is the derivative of our f of x, which is cosine of x, because the derivative of sine is cosine. And then our g prime of x will be the derivative of our g. Derivative of cosine of x is negative sine of x. Now all we need to do is plug in all of these into the formula right over here. So we've got f prime times g. So let's put these in their place. Cosine of x times cosine of x times cosine of x minus, and then we will have f times g prime. Now because we have a negative sign over here, we can just pull it out and cancel it with this negative sign over here, making it a plus. So this will be sine of x times sine of x. All of this to be divided by our g of x. So our g of x is cosine of x, so our denominator will be cosine squared of x. So what we're left with right over here is cosine squared of x in the numerator plus sine squared of x in the numerator. So let's go and clean that up a little bit. We can rewrite this as cosine squared of x plus sine squared of x. All of this divided by cosine squared of x. And for those of you that are familiar with your trigonometric identities, you know that cosine squared of x plus sine squared of x is equal to 1. So that can be rewritten as 1. So this is equal to 1 over cosine squared of x. Now 1 over cosine squared of x can simply be rewritten as secant squared of x, because 1 over cosine is secant, so 1 over cosine squared is secant squared. So 1 over cosine squared of x is equal to secant squared of x. And that is how you take the derivative of tangent of x using the quotient rule. Next up, we want to take the derivative of cosecant of x plus x squared. This one's a little messy. So this will be cosecant of x plus x squared divided by cosecant squared of x divided by e to the x. Now remember that our f of x will always be the contents of the numerator. The fact that there's a plus sign in the middle does not matter. Essentially, our f of x will be cosecant of x plus x squared. So f of x is cosecant of x plus x squared. Our g of x will be what's in the denominator, which is e to the x. So e to the x. And then our f prime of x is the derivative of our sum right over here. And we know that the derivative of the sum is the sum of the derivatives. So we'll be taking each of these derivatives separately. So the derivative of cosecant of x is negative cosecant of x cotangent of x. Negative cosecant of x cotangent of x. And then we add a plus sign right over here, and the derivative of x squared is 2x. And then our g prime of x is the derivative of e to the x, and whenever you take the derivative of e to the x, it's e to the x. Does not change. Now we just plug these into the formula that we've got right up here. F prime times g, subtract off f times g prime, and then we divide the entire thing by g squared. So we will have negative cosecant of x cotangent of x plus 2x, all of this multiplied by e to the x, and then we will subtract off f times g prime, so minus f times g prime will be cosecant of x plus x squared times e to the x, so cosecant of x plus x squared times e to the x. And then we will divide this entire thing by g of x but squared. So our g of x is e to the x. Now we want to raise that to the power of 2. So essentially what we can do in order to get rid of this extra exponent is we can just multiply them out. So e to the x becomes e to the 2x. Now there are a couple things that you can do in order to clean this up. In fact, we can factor out an e to the x from the numerator, and we can cancel out with one of the e to the x's in the denominator. So essentially what we can do over here is pull an e to the x out. We'll be left with negative cosecant of x cotangent of x plus 2x minus, yes, and then we've got extra brackets right over here, minus cosecant of x plus x squared. And then we can close our brackets. This e to the x will be distributed to each of these, just as we've got up here. And then we will divide this entire thing by e to the 2x, which can otherwise be rewritten as e to the x but squared. So e to the x times e to the x. Now we've got an e to the x in the numerator and an e to the x in the denominator that can be cancelled out with each other. So we can cancel these, and all we will be left with is negative cosecant of x cotangent of x plus 2x, all this in brackets, minus cosecant of x plus x squared, once again in brackets, all over e to the x. If you wanted to clean this up a little bit more, no, you can't factor out a cosecant of x. No, you're pretty much done in this case. This is all you can do in terms of simplification for this derivative. Most of the time your teachers are not going to ask you to simplify though, so this should be more than enough. Let's just go and fix this g squared right over here. Now we want to take the derivative of, I lost my page, of secant of x in the numerator. Want to take the derivative of secant of x over x squared plus sine of x. Just as we did in the previous examples, we take our f to be what's in the numerator, our g to be what's in the denominator. So our numerator will be secant of x. Our g will be what's in the denominator, so x squared plus sine of x. Then we take the derivative of each of these functions. The derivative of secant of x is secant of x times tangent of x. And the derivative of this is simply the sum of the two derivatives of each of the individual functions. So 2x plus cosine of x. Since the derivative of sine is cosine, the derivative of x squared is 2x. And then we will distribute it all into this formula. So we have our f prime times our g, and our f times our g prime, all of that divided by g squared. So this will be secant of x, tangent of x, and I'm going to need to write small because I'm running low on room, and this is going to be a very large problem, multiplied by x squared plus sine of x. Then we're going to subtract off f times g prime, which is secant of x times 2x plus cosine of x. All of this divided by g squared. Our g is x squared plus sine of x. So we can just write that out as x squared plus sine of x and then square the entire thing. Now we can factor out a secant of x. However, this looks pretty much done. This is already full marks on any test. So this would be the full derivative of our initial function. If you really wanted to factor out a secant, go ahead and do so. Product rule, quotient rule, and chain rule is very simple, plug and chug. All you really need to do is define your f, your g, your f prime, and your g prime, and then plug them into the formula. If you know the formula, you know how to take the derivative of any quotient, any product, and any composition function. Next up, we've got derivative of e to the x minus tangent of x over cotangent of x. Let's clean this up. So our numerator will contain e to the x minus tangent of x over cotangent of x. And the process is always the same. Our numerator will be our f of x. So e to the x minus tangent of x. Our denominator is our g of x, which is cotangent of x. And then our f prime of x is the denominator of the sum that we have in the derivative rather, the derivative of the difference that we have in the numerator. So the derivative of e to the x is e to the x, and the derivative of tangent of x is secant squared of x. And then our g prime of x is the derivative of cotangent of x, which is negative cosecant squared of x. And then we plug things into the formula as we normally would. So f prime times g is going to be e to the x. Once again, I'm going to be running low on space here. E to the x minus secant squared of x. Close brackets. Brackets are very important when it comes to using the quotient rule. Times cotangent of x. Then we subtract off our f times our g prime, which is e to the x minus tangent of x times negative cosecant squared of x. Now this negative sign and this negative sign are going to cancel each other out, so we can simply make this a plus, and we'll be left with cosecant squared of x in the numerator. And then in the denominator, we will be putting our g, but squared. So our g of x is cotangent of x, and we want to square that. So that will be cotangent squared of x. And that is our full derivative. You could probably do some kind of simplification somewhere, but this is totally fine the way it is. And then we've got our last example for today. Seeing as yesterday's video became abnormally long, I'm going to try to make today's video a little bit shorter. Since this is just an introduction to the quotient rule anyway, we don't really need too many examples because it's always the same process. However, when the functions get a little more complex, such as composition functions within quotients, then we'll probably use a couple more examples. However, this is pretty much the same process over and over and over. We're just learning where to plug things into the formula. So we have the function 6 to the x, 6 to the power of x, plus 3x, divided by arc cosine of x. Now that arc cosine of x is going to make things very nasty for us later on. So what we can do is we can define our f and our g. So our f is going to be what's in the numerator. So 6 to the x plus 3x. Our g will be whatever is in the denominator, which is arc cosine of x, or cosine inverse of x, whatever you'd like to call it. F prime of x will be the derivative of the sum that we've got here. The derivative of 6 to the x will be 6 to the x times the natural logarithm of 6. That is given by the formula that I provided in one of the previous videos with the list of derivatives. If you haven't already, go and check that out. Or I've got the full list on my website, whatever you'd like. So our f prime of x will be 6 to the x times ln of 6. And then plus 3x. The derivative of 3x will simply be 3. And then our g prime of x is the derivative of arc cosine of x, which is negative 1 over the square root of 1 minus x squared. Now this is going to make things a little bit nasty for us later. However, let's go and plug things into the formula as we normally would. Our f prime times our g, which will be 6 to the x ln of 6 plus 3, all in brackets, multiplied by arc cosine of x. Then we will subtract off f times g prime. There's a negative sign out in front over here. Will be subtract off 6 to the x plus 3x multiplied by negative 1 over the square root of 1 minus x squared. Since we have two negatives, these will cancel each other out and leave us with a positive. And we can add a denominator right over here and make this a 1 minus x squared. And this entire thing will be divided by g squared. Now we want to drag this into the denominator, and we'll do that in just a second. However, our g squared will be arc cosine of x, but squared. So what we're going to do to clean this entire thing up is we will multiply both the numerator and the denominator of this by the square root of 1 minus x squared. We're not going to change the value of the function. We're just going to be rewriting it in a different form. So we will have 6 to the x times ln of 6 plus 3 times arc cosine of x times the square root of 1 minus x squared plus, this entire thing will be added on to 6 to the x plus 3x. And then all of this will be over 1 minus the square root of 1 minus x squared, and then all of this will be over arc cosine of x but squared. Now what we can do here is we can drag this into the denominator, because whenever you have a denominator in the numerator, that can be flipped into the denominator. So we will flip this down here. So essentially all it is that we will be left with is the square root of 1 minus x squared times arc cosine of x all squared. And that is the derivative of our full function, and that should be simplified enough in order to get you full marks on your test. And I think that's about it that I wanted to cover in this video. Hopefully it's not as long as the product rule video that I made yesterday. That one got abnormally long. So the focus of the next video will be how to use the chain rule. It will be very similar to both the product rule and the quotient rule. There is a formula. All you need to do is define your f, your g, your f prime, and your g prime, and then plug things in wherever it is that they may go. And with all of that being said, I will see you guys in the next video. Thanks for watching.